Cyclones, tropical cyclones, and tornadoes. Let's try to make it clear. Sometimes, especially in the news, we hear about disasters caused by cyclones and tornadoes, two terms that are often confused with one another. While they may seem to be the same thing, and while they may share some of the same characteristics, cyclones are separate phenomena from tornadoes. Let's take a look into the differences. First, we will talk about cyclones. Cyclones are rotational movements of air and cloud masses around low-pressure centers that move through space based on their translation speed and motion. Rotation is counterclockwise in the northern hemisphere, clockwise in the southern. However, given their location of occurrence, we can still distinguish cyclones in two broad types: tropical cyclones and extratropical cyclones. They differ in their generating mechanisms, appearances, and affected areas. Tropical cyclones are powerful systems of extraordinarily violent wind that form over the subtropical oceans and intensify by extracting energy from the warm water. They are low-pressure systems with thunderstorms rotating around them, organized in spiral cloud coverage around the characteristic cloud-free eye. Upon making landfall, they inflict significant damages to coastal areas due to windstorms, storm surges, and heavy rainfall. Thereafter, they weaken quickly. Tropical cyclones are called hurricanes in the North Atlantic and eastern North Pacific, and typhoons in the western North Pacific. Hurricane was originally a Caribbean word for the cyclones that hit the West Indies. Extratropical cyclones are also low-pressure systems that take place in the mid-latitudes and are known for attaining a comma-shaped cloud coverage where cyclone centers are located in the head of the comma. Extratropical cyclones are much more frequent than tropical cyclones. They can correspond to weak systems, but they can also evolve into catastrophic storms with heavy rainfall and fierce winds. To understand how the so-called extratropical cyclones are formed, we must first understand how atmospheric circulation works in the mid-latitudes, roughly between 30 degrees north and 60 degrees north. These latitudes are characterized by the polar jet running around the globe, close to the tropopause, about 10 to 12 kilometers above the Earth's surface. When the polar jet is becoming unstable, it oscillates, giving birth to atmospheric waves that in turn impose sequences of high and low pressures. High pressure is related to good weather, and low pressure is related to cyclones and therefore is associated with bad weather.
Okay, so there are two ways that Mediterranean cyclones can be influenced by Atlantic cyclones. It can be directly or indirectly. So the direct way is rather unusual, is that Atlantic cyclones just move to the Mediterranean. The indirect way is via what we call the jet stream, which is strong winds blowing at about 10 kilometers height from west to east. And these winds do not blow like straight, they meander like a wave. And when they reach the Mediterranean, they are important for the formation of cyclones. And this jet stream can be influenced over the Atlantic by cyclones, either tropical or extratropical cyclones, which will accelerate the jet and amplify this wave. The cyclone remains over the Atlantic, but the wave and the jet propagate quickly toward Europe. And when they reach the Mediterranean, then they can influence the Mediterranean cyclones.
Tornadoes, on the other hand, should not be confused with cyclone weather systems, although they involve violent rotating winds, reaching peak speeds exceeding 400 kilometers per hour. Tornadoes usually take place within very small areas and are associated with intense convective cells, or what we call thunderstorms. An average tornado has a diameter of 100 to 200 meters, and they may last just a few seconds. Tornadoes are strikingly different from cyclones, especially concerning the spatial and temporal scales involved. Indeed, cyclones are weather systems with characteristic sizes of hundreds of kilometers, and they may last days and affect entire regions. In any case, one thing they have in common is that they are both catastrophic phenomena that need to be better understood.
We have tornadoes, which are narrow, violent, rotating weather systems, usually associated to supercells. They are also smaller in scale compared with tropical cyclones or extratropical cyclones. However, because they form between the ground and the cloud base of large supercells systems, they cannot be identified through satellite images. Meteorological instruments on board of satellite measuring visible, infrared, or microwave radiances have helped us to better understand the main physical mechanisms associated to these weather events, and more importantly, how to track the location, the movement, and also the intensity of them in real time, so we can provide warning to population with enough time to take safety measures.